Hello everybody, it is Mike Levin on Tuesday, August 2nd, 2022. And on this video, we will be sending an email with a file attachment from Python that starts out in Jupyter Notebook, gets moved over to a Linux service as a continuing installment of this series I've been doing. And I already did, between my last videos and this video, the work of expanding my email program, my SendMail program in Python, in order to use HTML for the body of the email text. We were using plain text before. Plain text is used now as an alternative, a backup for any email programs that don't support HTML displays. And I've also included an attached image that's able to be used in the HTML, in image tags in the HTML of an email. And I figure I'll demonstrate that now, because when last I left off, that was being done on a container, and it's running. Let's see. Well, you know what? I show it to you where we developed it. We developed it here, and I moved it out of my practice directory. It was getting a little bit crowded. And you will recall from when I started out, it was just a very, very plain vanilla email program, only this long, very, very short. And that's all it takes in order to send an email. This is my before, no new emails in that account. I run this, and there, email sent. Dun, dun, dun. And so here's a very basic bare bones email, and I'll delete that. Now I've been working my way up with different projects. You can see here that one was mail practice. Then I have HTML mail practice, which sends email that is just HTML as the body of the message. And do that one here. Email sent. We go over here. We watch it appear. Dun, dun, dun. There it is. You can tell the Dear You is a headline, and then the sign off is a headline as well. But what good is HTML without embedded graphics and then ultimately file attachments? So the one more I'll show you right now. And by the way, this code, if you're interested, you can go to mikelev.in/blog. And I've been pushing it all out here. So I think this latest attachment, which actually promotes this video, I've taken a little bit of time to promote these things before I live stream. Oh, well, it's the one before that. This is the code for the bare bones. This is the code for when we added just email. And then there's this third one here, which adds email with an image embedded. You can see I'm putting my logo in there. And I'll show you that code running. I guess we do a before and after, make sure we delete this last one, right? No new emails. And then we go to the one that I call HTML image mail. Run that one. Email sent. We go over here. And here it is now with an image attached. That's in an image tag. It looks kind of like an attachment, but I actually used a image tag right in the body of the text, so I could do design work with images in an email if I wanted to right there. So that's not quite the same as doing an attachment that has multiple files inside a zip, for example. So if you are doing something that has to like do scraping or screenshots and like send you the result on a regular basis so you can look at it and make evaluations, like a really good reason to write a heartbeat program is to monitor a website. So if you want to make sure a website's still running and such, you can do that. So I'm going to take this to the next step, right? So I showed you those bunch that are running, and now this next one, in fact, I'm going to close out of discard. The only one I'm interested in is the one that has attachment. And in fact, for memory, I am going to close all my tabs And then I'm going to shut down all my kernels because there's oftentimes stuff running extra in Jupyter that you don't really need. And then you can go back here and then just reload the ones you want. We're going to ultimately be plugging some new code into this one that's going to send with attachments, but I didn't really add the code in here yet. This is identical to the one that just has the image included with it, but we're going to be expanding it. So we're going to go to this one here where you saw me open the video with that cat that does not exist. So what am I talking about there? If we're going to put an attachment, we need something to attach. And since the internet runs on cats, I figured cats would be a really good place to start. So I at first started with this person does not exist because there's this lovely random face generator based on artificial intelligence and machine learning in order to generate a new face every time. And then I was like, this X does not exist. I'm like, oh, well, what's that? Let me take a look. Oh, this cat does not exist. Every time you go in here and every time you reload it, it's a new cat that does not exist. And the image is actually being returned as a graphic, as if this were a direct link to a .jpeg. It's really weird. If we were to right click and try to view source, you can see view source is ghosted. That confused me at first. And then I did what many developer type people do. You right click on an object and you go inspect, and it has nothing but the body and an image tag, and that's rendered. This is not the view source. This is what the browser does in response to what was received. So it actually decided to go ahead and turn this into a image tag because it recognized the page load as an image. So I was like, okay, well, I can do that too. I can do that in Python quite easily. In fact, it's really this many lines of code. We import requests, and we don't even really, to download it, need this. This is just to display it. In fact, if I were to, let's see, hide the output for a moment, put a new thing beneath it, and I'm going to move the code that has to do with displaying the cat down here so you can see how truly minimal the code is in order to retrieve a cat file. I don't care about PEP8 right now. So we import requests, and then we set a response object to request.get and that URL. This cat does not exist. And then with open, a file name we give it, and write binary as file handle. We simply file handle write the content of the response object. It might be better to be explicit about that as a response object by just putting RESP there. And when you do that, that hits that website and it downloads into a file here. In fact, I'm going to delete some things, right? Because we don't need, we want to show you the results of this stuff working. So I'm going to delete some files that are generally produced as a result of this process. The whole cats directory there. We can delete all that. It's not empty. So this is a little preview of what's to come. And so we're starting with a fairly clean slate here, right? So once again, to prove to you that these, 1, 2, 3, 4 lines of code downloads a file called cat, we just run that. It'll take a moment here for this to catch up with it. And there it is, it appears. Now I could probably just directly click it there. And because it's Jupyter, we could display it, as people will inevitably point out, by exclamation point square bracket cat.jpg and the title cat. And you run that. Oh yeah, can't, that's markdown. That's not code, so we change that to markdown. And you can show the cat that way. Let's see, cat.jpg. cat.jpg, cat.jpg. There's our cat that we just downloaded. But If we ran it again, it would not update the way the cat looks here. That's actually a caching issue with Jupyter. People who use matplotlib encounter that all the time. So if we ran that again, it would show the same cat. That's why I have this line here to show it, which every time we, so we'll get rid of this markdown. We don't really need that. Actually, it's just confusing. I wanted to point it out for people who are interested in it. And that's why each time we rerun this now, this will actually show the new cat that does not exist, that's been downloaded, right? And so that is just dropping it here, but that's not good enough for this zip file project we're doing. So I decided to do the code over here in Jupyter to work it out in experimental mode, as I often do. And then we'll actually just go ahead and move that file over into, I guess it's Munchkin, right? I'm exited out of it, but we'll get into it by, and I'll separate the types of work. We don't want to jump around what you're thinking about too much just yet. So I will go ahead and restart the kernel and clear all outputs so that you can see these things being run for the first time, essentially. One more of the main cat that just drops it out there. One more of the displaying it. And this is sort of a top level thing, but we need to create a directory and zip that directory. So first thing we need is the path method of the pathlib library. So this is a very growing in popularity standard library, a feature of Python 3 point whatever, that's replacing a lot of other stuff that people used to use to do this stuff. And once you're sitting on that path thing, you can do a whole bunch of neat stuff like check for the directory cats, and if it doesn't exist, make it. And if it already exists, that's fine, right? So I make the directory cats, but this is safe to rerun. I can run it again, it won't cause an error, because if it exists, it's okay. It's fine. Now let me take a look if anyone's with me right now, and I'll be sure to answer questions and check intermittently. 2 viewers, there's probably more than that because that is not a very accurate report. Okay, so what I'm going to do now is import something called glob, which is a way to do, checking directories for their contents. And I'm going to, from OS, import remove, which is a way to remove files. So I'm going to look inside the cats directory. I'm going to look at all files inside the cats directory. And for each file it finds, it's going to remove them. Now, there's no files in there, so that's not really going to do anything. And delete the old cat zip file. If there was already a cat zip file here, this would delete it. There is no cats.zip yet, so that doesn't really do anything. That comes into play later. And then we want to save a few cats into the folder, right? So I'll go into the cats folder. You can see it's empty for I in range 1 to 4. So that's actually going to do 1, 2, and 3. You'll see that in a second. I did that so that I didn't have to put a +1 here, right? The alternative would be for I in range parenthesis 3, and then I could just do +1 and get the same result. But I figured I'd keep it a nice clean I there as my counters in the range, and this will just go 1, 2, 3 and end. And yeah, I'll be explicit again. The response object is a request for this cat does not exist. And then we are going to write out that cat for each one, putting a little counter in there. Without further ado, let's grab 3 cats. It finished running. You'll see the cats appear here. Now to prove to you they're really there, we can go over here. That's GitHub. That's practice 3. That's cats. And oh, 2 of them are identical. I don't like that at all, and I don't even know how that happened. So let's run this code again back from, say, here. If there's any cats in there, we remove them. See, the cats are gone. And then we'll grab some cats again. There's 3 different cats. I like the looks of those cats. Those are good cats. All right. So Now we are going to, from zip file, import zip file. And this crazy Python convention, packages are almost always all lowercase, but methods, especially older methods from old packages, tend to have camel case. Very unPythonic, but we live with it, right? And now we will go back up to that parent directory of practice 3. There is no cats.zip file in there yet. And now there is. And I guess we want to assure ourselves that really exists. So we can go over to here, go back up to the practice 3 directory, take a look at cats.zip. It's about 500K. That seems about right. And we can, well, I'll just double click in to take a look. There's a folder in there called cats. I go into that and I see those 3 cats. I can copy them out. There they are. 3 cat images that were downloaded off of the web and dropped into a zip file. So that's kind of like the first half of this tutorial, because now that is going to become the file attachment, the actual process to create it, and the file itself is going to be incorporated into this other file we're working on here that has already been adjusted with all this MIME stuff. You see all this MIME text and different MIME things, MIME image, MIME multipart. I spared you sitting through me figuring all that stuff out, because it was a lot of just poking around and experimenting. And it just moved it from the bare bones version of the program to the supporting HTML email and supporting image embedded. So, right, I spared you from going from this bare bones version to this version here and this version here, but clearly it is very well documented on my website, and if you wanted to study the difference from file to file, you could. Now we're going to be going from this one here to just a little bit more complicated, and you can see this is where my logo is added. So right before, right down here, after we attach the image, that seems like a really good point to put in the zip attachment. Now I have looked ahead and wrote that zip attachment code to the best of my ability without actually doing it, and I have it sitting here, and I am going to try and transpose that, plus the stuff from the Jupyter Notebook here, right? So I guess I'm copying and pasting stuff from here into here. Now I guess I'll arrange these. We no longer need that launcher, and I'm going files from does not exist into HTML attachment, and it'll be a good example of, you know, just evolving some code, because this will eventually be just select all, pasted over on the Python, on the Linux side, much the same way the text appears here. All right, so missing imports. Those will include import requests, yeah, we're not going to really need to look at it to see our cat, so I'm not even going to import that one. Pathlib, I'm pretty sure we already have. No, we don't. A project that does not yet have pathlib at the beginning. That's always unusual. That's one of my first imports because it's so useful for so many things. And we will be importing both glob and the remove program. I'll put those up here to continue my nice waterfall appearance, although this one needs to go here for that to be true. And let's see, any more imports? Yeah, one more import for the zip library itself. And I'm going to guess that will look best here. Nope, it looks best here. Completely aesthetic, breaks PEP 8, but I like that look. I will put an extra line there as a concession to PEP 8ers. And yeah, those imports don't need to really be tested yet, but you know, I guess it never hurts, right? So I run it. When is a good time to test? Now is a good time to test. It's always a good time to test, which probably means I should be putting test coverage in here as well, along with logging, right? I should be using the logging feature more often. So it ran exactly as it did before. It's good to delete these now so that the next time I run the test, you see it appear fresh from scratch. All right, so what more do we need to transpose? We are going to be putting it here, as I pointed out when we looked at it in the blog, right? So when I show code like this, and then I, at a different point, show code like this is all the same stuff. So when I said we do something here, we do something here. And what do? We do all the same things that we do here. So these two are necessary. And we'll put a little comment to ourselves. Fetch files from web and make zip, right? So that will really apply to a series of lines, and I'll do less spaces in there because those spaces for informative reasons here become somewhat less informative over there as it joins a whole lot of other code. All right, so there's going to be a nice before and after here as well, because we can once again delete the cat's zip file. We don't need this cat running out here, although that is not going to appear as a result of this process because we don't do that parent level cat anymore. It's all from within the this folder, which I am also going to delete. And those should all get recreated now, and the email should be sent, although the file attachment, the zip, will not actually be made part of the email yet. Nonetheless, I have moved over enough moving parts that it feels like a good time to run it to test. Oh. File not found, no directory, cats.1.jpg. Okay, that's fine. That's line 67. So you click into here, you hit escape, and you hit L, Control L, Shift L to get line numbers, right? So when it tells you line 67, you can go right to line 67. And I am attempting to open a cat thing that doesn't exist yet, which means I did not do the requests part to drop the cats into location, or I didn't make the folder. What did I not do? I don't see a cats folder there. Yeah, so these are the attempts to put the cats into location, and it didn't find the folder, so there is a command here to create the cats folder that I must have missed. That needs to go. Let's see. Right above the glob command. All right. No such file or directory. Oh, it's looking for a full. Yeah, okay. So it's still line 67. Yeah, there's the requests up there. So I pasted this too low in the process. In fact, I have a, I probably have my order all screwed up because this is, oh, no, I didn't screw up my order that much. It's just that one thing. Huh. All right. It looks like the email is sent. And in a moment, you'll see this catch up, and there's all the supporting files now. The only thing remaining is to make that cats thing an attachment here, which I will strategically go in and do. I have the code all set up. But first, I guess I ought to delete that one there. And now, Let me check my viewers if anyone's... Hey, Paul Hagen, how did I find this channel? I'm lucky. Yeah, Paul, well, you're really early on in this process. I don't know what to say. I'm a slow build in the YouTubes. I've been at this for quite some time, but I'm only at still some 10,000 followers. I'm just not for everybody, I guess. So this next step here is you're actually attaching that file, right? So we have it sitting here. This is the magic spot here because this is where the thing was written. And I could talk through any of these pieces. I kind of spared you the work of me stumbling around, figuring out which library and, you know, writing them in and, you know, context manager. It looks like such simple code, and it is. It's really simple code, except there's so many nice Pythonic things going on that it really is more than what it looks like going on. That's seemingly corralled into simplicity. It's even hard to put words on it, but it's certainly one of the things driving Python's popularity these days. So the code to actually do the attaching is just this. I'll talk you through it once it's over here and has a little bit of color coding. But earlier on, you'll see we create objects that are calling the MIME functions, right? These are things that are imported up there. And we put some labels on the kind of data it's going to be. And then I'm doing with open, getting that cat's zip file. And in binary write mode with a file handle called ZFH for zip file handle, although it could just be FH. These things are really arbitrary. I'm saying that something called, oh, I don't even need bin. This is an extra line here. I forgot to get rid of it in my code. So I'm saying that that thing called mimecats, I'm setting its payload to reading out of the file handle, reading all the contents out of this binary read-only object. And then I encoded in base 64. Apparently it's something you have to do. It's just research that told me that. And then this sort of this last step here. Oh, I can't make that narrower. Okay, this last step here is just adding some headers. And I copied and pasted this from an old file example. Oh, and I don't even have a file name there. That is not correct, right? So this would not have run, but it's no problem because we want to do that as an F string. I have the old string replacement way of doing it here, but the file name is cats.zip. No, it's yeah, I don't even need an F string. That's going to be file name cats.zip. And I can get rid of the F string here. And I'm sure there's going to be some sort of error because this is untested code. I just wrote this kind of over in my journal, having copy pasted it from somewhere. I've done work like this before. And let's double check. A new object is being created, which is a calling of a imported thing from up there, right? You'll see that as one of these. MIME text, MIME image, MIME multiport. Which one was that? That's MIME base. Where the frig is MIME base? Did I forget to do an import? Yeah, that's the first occurrence of it. I am saving myself from an error, and I just need to figure out MIME base. So that's where it's located. MIME base. Let's see if I can do that smoothly and spare you the pain of struggling through this. It's not terribly dissimilar from these, so I'm fairly confident that it's going to be from email.mime base, import mime base, which will go up here. All right, so what else in here? It's just a context manager, which uses the thing we opened in mime base, and it calls one of its methods, set payload, and the entire dump of the binary of the file. And then we encode it. This is a something that has a side effect, because just calling that on it, I believe, changes it in location. I might check this by editing that out at some point. And then mimecats.add header, this stuff. And then message dict, which comes from earlier up there where we actually do these sort of things. That's where I attach the image. And now we're going to attach this object that we've been working on. Let's see if that does it. Run. If this doesn't generate an error, okay, encoders is not defined, so I need to import encoders. If it's even necessary. I hope this is not an unnecessary step. From email, import encoders. Yeah, look, email sent. This is a very suspenseful moment for me. Will it have a zip attachment or not? Oh, cats.zip. Look at that. It's got my picture, and then it's got this file here. We'll download that, drop it into this location, open that location, minimize my browser, drag the zip out here, open the zip. We see the folder inside of it. And there you have it. There's the 3 cats. All right. So we know our Python script is running. And now we go over to our container area. Now, for those just joining me, I can never show this too often. I am using the LXD, pronounced LXD, container system. It's like Docker, but allows you to do the kinds of stuff people really want to do as a developer, which is containerize your whole system, not just some application directory. So you can research that on your own. LXC is the command that controls containers, and we can do an LXC ls fast, which shows me my containers that are running. Munchkin is the one that I've been doing this work on. It is in fact running, and we can log into it with LXC execute. So this is to execute a command on a running container. Which container? That one. What are we going to run? -- space, switch user, login, standard user, Ubuntu. Now we are Ubuntu at Munchkin. I'll try and get my pronunciations right. People correct me on it. I know it's Ubuntu, and when you sudo, it's sudo and not sudo because of super user do. It's not super user do. Anyway, we can check to see whether the service I'm going to be plugging this into is running. So Systemctl status pulse. If you followed my previous videos, you've seen me developing this pulse service and evolving it from a busy wait loop that just sends a timestamp out to a file in the screen to one that you can monitor through the GNU screen interface. So I guess I'll get this running now because it's not running. Oh, it's enabled. Active failed. All right, so whenever anything's locked up like that, hitting Q is the way to get out of it. So we'll try starting it. When you start a service, you go sudo, the same systemctl command, start pulse. Okay, it started. And now we can look at our screens that are running because I run this through the GNU screen command. So when we do screen -ls And it's funny, see, ls here is an argument of lxc, doesn't use a minus in front of it, but it does use a minus in front of it here. These are the little things about Unix/Linux that kind of bother me, but not so much that I'd ever, choose Microsoft. I mean, try and do this kind of stuff on Microsoft. I mean, this is free, this is open source, this is wonderful tooling. There's just a few nuances here and there you really got to deal with. So I can now look at the running service by going screen, reattach to Pulse. And now we can see the Pulse service has started, and every 5 seconds it's writing out a timestamp, and every 10 seconds it's writing out a hello world, right? So probably every minute I'll send one of these emails, and every minute I'll get 3 different cats in a zip file in my email. Oh, look, email sent, right? Okay, so this was me doing the test before without the email attachment. So I already made this service able to send emails, right? This is almost exactly what this demonstration is going to be about. So we'll go see that email. I minimized the browser, didn't I? And I'll check what you folks are saying. So there it is coming in again. This is sent from the service, and it will continue to be sent from the service every minute or so. There's going to be another one coming in a moment. So I'm going to stop this service. We'll see one more email come in just to hit the point home of what's going on here. And then we'll stop the service, and then we'll replace the .py file that represents this service with the one that sends the cat attachment. There's one more send email, and there it is, new message, inbox, and there it is, sent again. So we're going to stop the service. The way we do that, even though we're monitoring it here, and we could Control-C out of it and stop it, because it's a service, it will rigorously restart on its own. So we do Control-A, Control-D to detach from the screen, and then we use that command we used to start the service, but we just use it to stop the service, right, like that. So the service is no longer running. If we were to try and get into that screen, the screen is just not there. If we were to list the running screens, there is no sockets found to the GNU screen terminal server. All right, so for anyone who's been following along, you know that there's 2 files that comprise this. The first one is, as you would imagine, the Python file, which we'll get to in a moment. But more importantly to the whole systemd system is this magic location. So I'm going to do Control-L to clear the screen, and then I'm going to CD just to show you the location. It's always in etc, it's always in systemd, and you can do command line completion, right? But there's a few things in there that begin with that. So you have to go T before command line completion. We'll get systemd, system. And so we can look in there, and you can see a bunch of systems that come standard with these Ubuntu container templates that you pull down from their image server with the LXD, LXC system. So all of these are either directories or symlinks to other locations, except for the one file we dropped in there directly. Now we don't even have to edit it. This is just a reminder, vim pulse.service. I couldn't edit it because I didn't sudo vim it, and this isn't a privileged location, but you can see the file, the Python file that this service is referring to is in home Ubuntu GitHub pulse/pulse sendmail.py. Now I'll do probably pulse send attachment, send cats, right? Send cats. Make this a popular video. All right, so we quit out of it. And in fact, I'll sudo vim it, right? I couldn't have edited it before, and I didn't think I was going to be editing it, but now I realize I'm going to be changing the name of the file. It's not sendmail, it's sendcats, pulse sendcats, right? In Python, in Vim, you hit to save, you hit escape, you hit colon, and you hit W. That saves it. You repeat the process, but with Q to quit. Okay, and so now we go into that location, which is CD. I can go long way. I can do home Ubuntu pulse, home Ubuntu GitHub pulse, right? So that would CD me into there, but everyone should know that this whole /home/Ubuntu, there's a very useful shortcut, which is tilde. That's always your home directory. So I can cd into tilde/github/pulse. I can ls in there, and you can see I've had a few versions of the Pulse program. I've had a standalone sendmail program that I've tested in here. But what we're going to do is we're going to vim a brand new file, pulse_sendcats.py. Enter, insert mode, over to Jupyter, select all, paste, escape, :w, quit, and we'll do a before and after. Let's delete all the emails from this service that might be sitting here. And now let's start the service again. There's no reason this shouldn't start sending me cats. I could have just typed it more quickly. Sudo systemctl start pulse. If it doesn't complain, oh, yeah. It knows, it can detect when your configuration file, which is what that .service file, changed on disk, and it instructs you to do the reload. Now we will want to sudo that. Reload, get rid of that single quote that I let slip in there. Now that reloads the service. Now that the service is reloaded, because I changed the .py file name, I went from pulse_sendmail.py to pulse_sendcats.py. Because I changed the .py file that service file was pointing to, I had to do this reloading of the daemons. But now I can start the Pulse service. I can screen ls to prove to you that came back, and I can screen reattach to Pulse to get in there to monitor it. Now that's a lot to have written out since I restarted the service. I doubt, see, it's sendmail, it's not the right one. All right, Control AD, sudo systemctl stop pulse, sudo systemctl daemon reload, sudo systemctl start pulse, screen reattach pulse, screen reattach pulse, screen ls. Systemctl, systemctl status pulse, loaded, activating. So something is keeping it from running. So the way to test this now is oftentimes to just run it purely as Python to see what's happening. So I'm going to do sudo systemctl stop pulse, because there's no reason for it to be running sort of twice. I am also going to vim it one more time. We don't have to sudo vim because we are the owner of this location here. It's only /etc/systemd/system where we're not the owner. In this process, there's plenty of other places in Linux where you're not the owner, but in this process, we own our Python here. So that's Python, that's pulse sendcats.py. Now, one thing that I know I forgot to do is where you actually write out to the file. There's a text file that I write out to with a don't I write out to it? Oh yeah, no, not in this. The pulse, this just handles the email, right? Because the scheduling is handled elsewhere. Boy, I've got to show you that because okay, think this through. Think this through. Yes, I remember. It's coming back to me. It's all coming back to me now. LS. Pulse scheduled. Pulse send mail. Pulse send cats. I should have started with pulse scheduled. I need to look at that. I copied a very equivalent of a single event, a single send mail event. So I optimistically pasted it in there like that without understanding that what I'm really doing is continuing probably pulse scheduled. Vim pulse scheduled. You can watch me correct my errors, okay? So in pulse scheduled, we import schedule, and that loads external programs, right? This is how we turned, yeah, of course. This is how we turned the earlier pulse versions into one that can load an external program. Yup. All right. So let me look at those other ones. Vim pulse send mail. Yep, this is the more advanced version of the scheduler that supports external things. So what I really need to do is in pulse schedule, change the send mail program to instead of send mail, it should be send cats. And I am going to change the name of the file accordingly. Sudo move. We don't need sudo, it's just move. Pulse send cats to just send cats, because something else takes care of the responsibility of the pulse now. And I have not changed the .service file, so I really should, I don't even need to reload it because I stopped the service. I should just be able to start that service. Okay, should be able to start the service. It did not complain. Screen, ls. Oh, no sockets. Let's stop it again. Bear with me. So doing these types of things does take thinking it through and does take remembering. And let's see. So I am interested in the thing that's, oh yeah, so I changed it in the .service file. I will need to put it back to, let's see, is it pulse scheduled that has the advanced thing? No, pulse scheduled is not the advanced one. Clear, ls, vim pulse, and I'm going to rename if it's send mail. Yeah, that's not the advanced one. Oh, yeah, there it is. It has this run command, so that's the advanced one. The concept here is no longer send mail because it's just one of the schedule items. Sending the mail is just one of the schedule items. So we are going to move pulse send mail to just it's the new pulse. It's pulse scheduled technically. It is pulse scheduled, but I do want to keep that one there for historic reasons. This is a scheduler. It's the scheduler. It's just the scheduler. We now have a scheduler. Sudo vim etc systemd system pulse. I probably ought to rename it there as well. but I don't want to do too much to confuse us all. Scheduler. Save, quit, right quit, and sudo vim scheduler. And now I'm going to make sure that I'm writing out the files the way I want to. So this is just going to be scheduler.txt in the temp file. So it's going to start a new temp file over. So people who have been following me in these videos will know what I'm talking about in a lot of this stuff. People who are joining in the middle, maybe not so much. So the pulse command and the send mail command are two different things that get scheduled down here. We have scheduled the pulse command, we have scheduled the send mail command. So when it does pulse, it is going to write out to a file in temp and stick a timestamp in there and print out to our screen the fact it did that. And then when it hits the send mail function, it's going to use the Python executable located there, and it's going to use that as my current working directory, and then it's going to run sendcats using the Python executable, current working directory, sendcats. And that, I think we're finally there. And now we will have to do a sudo systemctl daemon reload, sudo systemctl start pulse. It's still named pulse. I may change that at some point. And it didn't complain. We can do a screen ls. Oh, there it is. There's pulse. We can now screen reattach into pulse. And there it is. We should see the email get sent. Now let's set up a good before and after. This is one that got created in testing. We don't need that. Just as a reminder, this was not scheduled. This got written as soon as the service started to run. These pulses are every 5 seconds. These hello worlds are every 10 seconds. So it's 5, 10, 15, 20, 25, 30, 35, 40, 45. Hello world, 50. 55. Hello world, email sent. Oh, okay. What didn't it like? Oh, module not found requests. Requests is not on this system yet. Control A-D. We want to install it underneath the virtual env we have running. And we do that by source ~/py310. Oh, there's so much that builds on prior videos here. Bin activate pip install requests. Go back into the screen, Control C it, wait about 5 seconds, go back into the screen. Pulse service has started. That was an alternative to restarting the service, Control C'ing it from inside the GNU screen login. Now, unfortunately, we have to wait through this to get up to 10 entries again on these pulses, so I will use that to take a look to see if anyone is typing to me. Been watching your videos lately. Keep up the good work. Thank you. Thank you. I will. Let's see if it's good work. I don't know yet. We'll find out. One, two, three, 4, 5, 6, 7, 8. 2 more of the timestamps to go. 9, and 10. I don't think I counted right. That must be 10. Sending email. Some sort of file. Oh, my logo file. It didn't include one of the logos. So the email will be sent, but my logo will not be there. And I'll show you how to move the files around like that logo. It's sometimes so hard to move files around in environments like this. So first thing, we'll just double check to see that the email came in with the attachment. Oh, maybe the whole thing did not run because that file was not found. That is exactly what happened. So we will we'll move the file over, and then we'll just do a Control-C on this again. Let's open another terminal to the oh, there's my logo, so I'll keep this over here, but I want that there because over here I'm going to open another terminal to Munchkin LXC EXEC. I need to create a parameterized alias or something for this. Munchkin SU login Ubuntu. So now I have two logins to the same server, one which is monitoring this and it's going to have the error each time, the other one which will do some work from, and then this screen here where we see we have the logo right there, and I'll put this here. I'll put it over this side because source and destination, and we will simulate Norton Commander and all that stuff. So I bring up another Explorer, put it up over here, and then I just go to my data folder, which is my D drive on my system these days. And you can see all my experimental work. I even have my Mike Levin logo in there. But you can see all my cat experimental work these days. I'll delete those out. And then I'll just copy my logo over. Oh, it's already in data. So I just have to, I don't even need these things. This was all a wild goose chase. All I need to do is to CP data, my logo, GitHub Pulse. And when you give a directory name like that, it knows to put the source into the destination. It doesn't replace the directory. It knows to do that. I go back here, I do a Control-C. Wait long enough for the service to be recognized as not running. Go back in, it restarts, and we will be waiting once more. I should probably speed up the duty cycle. Right? This wait is defined. Now that I have this going here, I can CD into GitHub Pulse and remind you by looking at the scheduler. Oh, it's not, see, just CDing into there, and then Vim scheduler. And I can remind you by looking at the scheduler where this is defined. So every 10 seconds is the hello. Every 5 seconds is the pulse, and every 1 minute is the send email, right? So we're getting there. And I'll do some control minuses just to hit home how little code that really is to do a scheduler. There's not much code. Sending email. And there's no error. There's our cats. Sent from the server, sent from a Linux container running a daemon that is capable of scraping the web and emailing you file attachments of what it found. Think of the applications. Ugh, wow. You should all be paying for this. Anywho, let's see if anyone's there saying stuff. Yeah, okay. So that really gets to the end of this video. I have done a few stumbles along the way, but that's a part of live casting and the genuine experience here. So you'll see it send the email again. And for people who are joining in the middle of this whole series, I guess I'll give a little overview. Maybe I'll do a picture. Is it picture time with a stylus? And there the email is sent again, and it'll just be sent over and over like that. It's not the ultimate, purpose here. It's just, to send some cats was a zip, to show you the techniques. So let's do one final piece of cleanup. Control A, Control D, detaches it. I'll stop the service in the correct way. Sudo systemctl stop pulse. And it's no longer a pulse, it's now a scheduler. There was a pulse. Pulsing is one of the things that's scheduled, right? Pulsing is one of the things that's scheduled. So I am going to clear the screen, do an ls, and take stock. I look at this, I take stock. There's things that are no longer necessary in here that are sort of for historical reasons that helped us get to this point. So I will make dir. I will make dir with a name, old. And then I will move the things that are no longer necessary. We're not using just the normal pulse.py. We'll move that into old. We will also move send mail into old. We will also move, I do believe it's even pulse.py and pulse_scheduled. Oh, I did that already. Oh, I need to give it a destination, old, clear, ls. It's much easier to look at now. So, there's the files that are involved in the process, the directory where things are scraped into, what the directory is compressed to, so that everything in this here, I should ls-la, right? So that you can see what's a directory and what's not. This D here means cats is a directory, and everything in this cats directory is zipped up. See that 500K? That's about right from what we were seeing on the Windows desktop. That's put in there. These two files are the to and from email addresses and login credentials in the case of from. And this is my logo, which is an extra little attachment that gets thrown in it to the HTML email to prove we can decorate an email. And then because I'm editing these things in Vim, I have them with .swap files here. Do I? Yeah, this one. There's two swap files. That sendmail.py is not a swap file we need, ls. I should probably turn this into a Git repo and as the bonus, ls-la, and do a git ignore on the .txt files, because those can't get included, and on the old. And yeah, let's change the name of the service to scheduler. All right, so I'm even going to change the directory to scheduler. cd ... sudo, that's not even a sudo, it's just move pulse scheduler, ls. Right now the directory is called scheduler. Inside there's a scheduler.py. It starts to make a lot more sense, and the whole identity of pulse is kind of being erased here because pulse is no longer the point. Scheduler is the point. And so the last place to eradicate the concept of pulse, except for where it's scheduled inside the scheduler, would be in the service. So we'll quit out of this because I'm tired of looking at that .scheduler. So if we do that ls-la again, you'll see that the .scheduler, oh, I thought the .scheduler was going to be gone by quitting out of Vim, but it's not. That's very interesting. So somehow these temp files from Vim get left around every once in a while, and you do want to clean them up. They don't cause any harm except for annoyance. So final step, cd etc systemd system ls sudo move pulse.service scheduler.service. We're renaming a service. And honestly, this is all the benefits of systemd. Now that we rename that file, we should have that same exact ability to sudo systemctl start scheduler. ls. Okay, it is in there as scheduler. We'll reload all the daemons. Sudo systemctl daemon reload. Start the scheduler service. Failed because exited with error code. Okay, so we're going to go back to the location. cd ... cd scheduler ls, and we're going to see why that has an error on run, which you can always test by using the long paths to Python. Long path to Python is home. Ubuntu, Pi 310, bin Python 3, and then we're in this directory, so we can just do scheduler.py. Pulse service is started. I mean, it hasn't really started. That's just what gets written out. Oh, look, it's actually working correctly. So I have something pointed at something wrong. It's still in the fact that this is working means I got the .py file right. So something is definitely wrong in the .service file. So we just go back into there again. Sudo vim scheduler. We're going to find paths to pulse in here is what's going to happen. Yeah, of course. That's not part of the path. That's going to be the name of the screen. So the screen is going to change from being named pulse to being named scheduler. I like SCHED, sched, so I don't have to type so long every time. Boy, I really missed it in a lot of places. There's probably people watching the video who are yelling at me going, come on, don't miss such an important detail. So now the daemon reload should go smoothly if it's even necessary. The system start of the scheduler service should go well. Attempt to look at the screens with the ls command should be smooth. We now have sched instead of pulse, and now we can do screen reattach to SCHED. There's our renamed, rebranded scheduler service. And we will delete all of this thread here to watch our cats get sent to us again. And this is a good time to check for whether anyone said anything. I'm new to Linux. What is systemctl and how is it running a Python file? Yes, well, I should really refer you to the prior videos, but I know I don't have them organized so well to just step through and see. So systemd is the new way that services are managed on Linux. It used to be an old way that very few people had the, oh, screen terminated once it got up to that. Ooh, that was not good. I should really have allowed this one to run all the way to get through a full 10 to the email. We'll actually do that here and see what happens while I answer the question. Systemd is the way everything under Linux is run as services. So if you're running a web server or anything in the background, it's running under systemd as a service. These services are called daemons. Okay, so that's the systemd thing. It's replacing something from the long ago that was kind of universally hated because it forced you to learn something called bash script. So this is all replacing stuff that used to be difficult in Linux that has recently become fairly easy. You're seeing me doing it without editing a line of bash script. And so now it brings a lot of stuff into the capability of mortal users. People are like, oh, I'm a real life Guilfoyle or whatever. I am not. I'm more like a very average user who just is intrepid, right? I'm not scared of facing this stuff. So let's see what this error was. Oh, no such, yeah, there's one more reference to Pulse, and that is it might be in scheduler line 54 or in something else that's in the picture. So we'll vim scheduler, abort. I might have it loaded already. I don't, but that's that remove.scheduler swap file. Now we'll vim scheduler again, jump to line 54. Yeah, I still have references to Pulse in there. To Pulse paths. The working directory, the current working directory is now scheduler. And because it's only the .py file that I changed, you will notice that I don't need to reload. I don't need to do any of that reloading stuff. In fact, all I have to do is reattach the screen because I know it's been attempting to reload it all the time. So to answer your question a little bit more, one of the things systemd does is attempt to reload things all the time. If they stop running, this will force it to reload. So let's get a before and after. So no emails, no current unread emails. This is almost up to the point where it sends it, and we're going to see it get through a full pass here. And then I'll answer the question in more depth. These live casts like this, oh man. All right, well, we'll do this one more time. Oh, I don't want to full path to it. Did I do it from here? Sometimes you lose where you did this stuff from. Yep, I did it from there. It's probably too long to wait. I should probably edit that scheduler file so I don't have to wait for so long. I have the email sent every like 5 seconds or something. But this gives me a little chance to talk. Yeah, Lewis, okay. Systemctl is running a Python file because there is a file in a magic location here that refers to it. This is the definition of a service under the new systemd, under Linux. This is what it's running. Full path to the Python executable and full path to the scheduler file. This other stuff here is funneling it through a screen program that lets me monitor it. Okay, email sent, no error. Let's see the email. There it is. We'll delete that. And we'll wait for it to go through another. Oh, well, now I can Control C out of here and run it as a service, because you can see I just ran it directly as Python, right? So there's running it like this to test it. And I give this full path because I'm using Python virtual envs. And if you don't give the full path to the executable, you don't know whether it's going to find the pip install schedule module, the pip installed requests module. So by giving the full path to the Python executable, you can test things that you are getting ready to run as a service. Now, how do you run this as a service now that it's being pointed to by this file? When you think systemd, you also think systemctl. Systemctl controls everything that is run under systemd. If you want to know what systemd really is, you can, well, first of all, I'm going to make sure the schedule, the thing, it's not attempting to be run as a service right now. So I'm going to go sudo systemctl stop sched. Okay, it's not loaded. I didn't really need to do that, but I wanted to do that in order for me to show you this, and with peace of mind that it's not continually attempting to run and, you know, sending those emails and stuff in the background. So the PS program under Linux shows you what's running as your current user. So right now we're only running this bash terminal that we're in. This is called a bash terminal or bash shell. Linux terminal, a Unix terminal, the text interface, the command line. There's lots of words for it, but as a task, it's called bash. The PS program itself, to see what programs are currently running, is that. Now, it's limited to just our user, but that doesn't stop us from investigating certain task IDs. So I can actually look at PS1 and I can see that the first task ID, so it's process ID 1, is sbin init. Okay, now the question is whether that sbin init is systemd or the older system. It could be either one. And oh boy, the way to do that, ps -o com. It changes the columns that come back. And pso com 1. It's not easy. And there it is. You can look at a different column for the ps command to see what the name under the command column is for task number 1. And if you see systemd there, you're on a system that's running systemd. But you hardly even really need to check. It's on everything except, of course, for the Windows subsystem for Linux by default. So I had to enable systemd on the Linux container, on the Linux system that's hosting these containers. Oh my goodness. Go back a bunch of videos and follow my videos one by one. It will clarify. There's a lot of nuance here that, you know, is the new knowledge of Linux. The new knowledge of Linux is what I'm talking about. Okay, so let's start that scheduler. Sudo systemctl, right? Because systemctl is the way to manage everything that is under systemd. You want to see everything that's running before I even start it? You can just type sudo systemctl on its own and use the J and the K key to run up and down to see everything. Oh look, pulse service not found, failed. So there's still something like that trying to be loaded. That's okay. That'll go away probably by a restart of the system. I'm not exactly sure. But at any rate, clear sudo systemctl start sched scheduler. Screen ls screen reattach sched. Oh, it's been running all this time. That's why my attempt to, I should not abbreviate the screen to sched because that's going to make me think sched when I start and stop this. So I'll do this one last thing of I'll keep the whole screen name scheduler. And with a change like that, I do need to do a sudo systemctl daemon reload. Oh, yeah. I'm just being really cautious now. There we go. All right, all is good. This is the way I actually want it, and I'll probably push this out to GitHub so people can look at the code and examine it for themselves. Let's see if there's any questions. There's probably tons of questions. So there it is with my cats. And each time, by the way, this is a different set of cats, right? It might be entertaining to do that just to show you that, you know, it's different cats every time. Oh, I put it in my downloads, right? It's getting late, isn't it? Desktop. Downloads. Oh, they look like the same cats. Yeah, the containers are definitely worth researching, and all your research into containers is going to lead to Docker. So there's actually a recalibrating going on in the whole world of Linux right now, where Docker has very much changed the world. However, it's changed the world for App Store-like stuff. Being able to quickly plug in software and run it. It's appropriate for app stores and creating installable software. When you want to have playgrounds of the whole system, LXD is actually better than Docker. It's an amazing thing, but you know, you'll basically want to research containers, and then you'll want to research LXD versus Docker. So basically Google Docker versus LXD as a response to figuring out what containers are and why they're so great and why they're changing the world, right? So I'm kind of done, except for the fact that the cats look the same in that email. I might have grabbed it from the wrong email. I don't even know. So let me delete these. Let me delete this. Oh, no, there it is. These are different cats. There was a repeat of a cat here, and there's a repeat of a cat here. That's very interesting. There might be caching issues at play, but that was a Windows display error. Different cats, although there are dupes. But the essence of the demonstration still is very much on target. So while I have people here, I can give you the education about containers and stuff. I can do a diagram. I have my stylus. So let's go over here while I keep getting more cats sent to me. So I give you the education. We almost always start these things with a drawing of a box representing your hardware. Oh, why is that fading out? Pencils don't generally fade out. It's probably because it's making that thing disappear. That's why it was. So this is very much your hardware that you're sitting in front of your laptop usually, right, for most people. And on your laptop, you're almost always going to have Windows. This is a diagram that my folks out there have seen me draw quite a number of times. So Windows is normally all that's on your hardware. There used to be all this attempts to do multi-boot systems and all different ways to also get Linux on your hardware. But now, thanks to the Microsoft Windows subsystem for Linux, Linux can live right next to Windows as a first-class citizen. That's how I can have these terminals here, which are really, I guess I'll pull up another one. Like having my broadcast software on the last screen. So that's how I'm able to pull up these things here, which is the same thing as, I guess, going into here and typing terminal. And you get this terminal app on your system after you do this step, which is you can pull up the PowerShell. So if you want to do what I'm doing right now, just pull up the PowerShell, run it as administrator, and then type the command WSL install. And that will put that'll put Linux on your machine, just like I did in the diagram, side by side. That will get you this, and it will be running side by side with Windows as being just as much of a first-class citizen as Windows itself is. Now, I'm really reproducing an old diagram I exactly did. This is made possible because of a piece that gets turned on in the process called the hypervisor. It's almost like an operating system in itself. And it was a piece that became popular because of multi-core systems and the attempts for people to run virtual machines and stuff. So it all became formalized and incorporated into the hardware, right? This hypervisor level is very much a hardware issue these days. It's much less software than it used to be, which is what allows all this virtualization technology to work. Now, by default, it's going to put Linux Ubuntu 20.04 on your machine. I don't like that. I go out of my way, to make sure I have Linux 18.04. Technically, it's Ubuntu 18.04, because that makes installing a piece of software called LXD very easy. That becomes very easy to install when it's 18.04. And with LXD on your system, you're able to spawn off tiny little Linuxes. These magical little boxes. Like this, and you can have as much of them as you like. You can turn them on and off. They're a lot like virtual machines, but they're better than virtual machines because they're very high performance. They have very little system cost to you. So you can, make these into a playground, into a sandbox. And it's great for learning Linux. This is where you want to learn Linux, because there's no mistakes you can make that are really that bad. If you make a mistake, you just nuke one of these and you create another. And that's what I'm doing over here. That's where all these things are running that you see me running now, right? So if I were to exit out of that, you see this Ubuntu at Munchkin. That Munchkin host name is one of my containers. If I just type exit here, you'll see me exit out to the host machine. The host machine is Lunderwand. And if I list my virtual machines with the lxc command, ls, I do fast just so it doesn't wrap, you can see that I have 1, 2, 3, 4 different virtual machines. Only one of them is running. And inside of it, this system is running. This is running in one of these boxes, right? In this diagram here, everything, one of these is called Munchkin, right? And this is where I'm working right now. And you get that by having Ubuntu 18.04 as the easy path. There's other ways to do it, but when you have that, all you have to do is, once you have that installed, is apt, well, let me modify that. It's sudo apt install lxd, and that puts it on your system. And then after it's on your system, you type lxd space init, and then you type enter, 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 enter through the wizard that comes up, and you've got this system here. You'll have that system on your machine. Now on this blue screen, there's a way to keep it from installing Ubuntu 20.04, and that's by doing -d to define which distribution you want and typing Ubuntu 18.04 like that, and that would start a install controlling which distro you get to only 18.04. And if you're looking for where some of this is documented, you might have to fish a little bit, but it is in fact mostly on my website. So you can go to mikelev.in and go to my blog. So it's all documented somewhere in here. Oh, it's getting big. But you can go from the current stuff and then travel backwards in time by doing previous, 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 and go through my whole process that it took me to get to this point here where I am at. All right. I would appreciate that. Yeah, I have Ubuntu WSL, but I haven't done much other than install it. So if you've installed WSL, are you on Windows 10 or Windows 11? Because if you're on Windows 10, you're going to have to do a couple of steps to get all this WSL stuff upgraded to what they call WSL 2, which has a lot more capabilities, a lot higher performance, and is certainly necessary for all this container stuff that I'm doing. So there's a lot of ways for this to all go subtly wrong. One of them is to get Ubuntu 20.04 instead of 18.04. It makes the container stuff harder to install because it forces you into the Snap Store, and there's all kinds of little subtle mistakes. Oh, Windows 11. Okay, so with Windows 11, that means you actually have WSL 2. And so when you have WSL 2, you could just install another copy of Ubuntu, right? Because you certainly have 20.04. If you want to get 18.04, one easy way to do it is to just go into the Microsoft Store. You see, I don't keep many icons here. I don't use a lot of different things on the system. But the Microsoft Store is one of them. And in the Microsoft Store, you can search for Ubuntu 18.04. 18.04.5 LTS. That would be a good version. You can see owned. I use that. And that is because, and it's a very nuanced point, this will change. 20.04 will be just fine, and using it through the Snap store will eventually be just fine. But until that's the case, after you go into a terminal, your attempt to type sudo apt install lxd, and before you do that, you always want to do a sudo apt update to make sure that all your repository is up to date. And then when you do lx, after it's installed and you do lxd init, you want to be able to just enter through the wizard. And it spares you all these very technical decisions that you have to make, that you're forced into, and that you have to change. Then you have to know magic numbers if you're on 20.04 and you use the Snap Store approach, or if you try to do the sudo apt install under 20.04, you can't just enter through the lxd init wizard. And that's a nuanced point, but it makes so much of what I'm doing today doable, whereas it's a stumbling point, it's a showstopper if you don't start with exactly the right components to streamline the process. And so it's all good. This is stuff for noobs, because noobs should be able to have access to all this. How do the apt repos work? Like, how does one command fully install new software? Okay, so I can demonstrate it. Let me create a new container for you so I just show it. So here's my container so far. So what I'm going to do is basically make it look like it's a new Linux system, right? You don't have to use containers for the step I'm about to do. You would do this on a fresh install from the Microsoft Store or whatever. But in order for me to do a demonstration, I am going to lxc, they have the weirdest word for this, launch images Ubuntu 18.04 as Huey, Louie, Dewey. Creating Dewey. Registered image couldn't be found. Oh, 18.14, 18.04. Oh, yeah. Sorry, my fingers are getting ahead of, my brain is getting ahead of my fingers. So I go to my notes, lxc launch images. Oh, so slash, it's got to be a slash in there. Creating Dewey, right? You see there's only the 4 there and there's no Dewey. But now if I lxc-ls fast, lxc-ls fast, you can see we have Dewey there. Now I'll enter into Dewey by lxc exec. You're executing a command. You're executing a command on Dewey. It's nuts. I gotta find a better way to do this, but you're executing a command on Dewey. -- space, another terrible API thing, but you got to live with it. Switch user, login, user Ubuntu. And what you're about to see is as if I did a fresh install, right? So I'm in Ubuntu Dewey right now. So I'm going to clear my screen, and it's just like we have a fresh install of a Linux system. The first thing you do on Debian-based Linux systems, which Ubuntu is, so there's different ways of doing this out there in the Linux world. There's a one big major split. It's between the Red Hat way, which we're not using, which uses Red Hat Package Manager, RPM, and Yum. It's supporting programs called Yum. But on this side, it's the Debian Package Manager, and it's supporting programs, which in our case is apt. So super user do. Some of these things you have to do as super user. This is one of them. The apt program, update. This updates your whole local software repository to make sure that you have a copy of all the latest and greatest stuff. And then given a name of something you know, now there's a way to see what's available, but given the name of something you know is available, you then do sudo apt install and then just the name of the software. I mean, there's so many things you could get. I don't know. You know, when I get up to this, I'm stuck at it. But you know, let's install something. The screen program is not normally installed on it. This is one of the things I install early on, and it says, you know, reading the dependency tree. Do you want to continue? Yes. And so now this thing that I use a lot in these processes called screen is installed. It's there. It wasn't there before, but it is there now. I can do screen -r blah, and I just created a new screen terminal. It's just a way to switch around and control where tasks are running. You can exit out of it, but I wasn't able to do that before. Git is not even on the machine. These very small, minimal Linux distros don't even ship with Git. So again, you can do sudo apt install git. This is a pretty large install. It's going to go on for quite some time, but that's how you install software under Ubuntu and all Debian-based Linuxes, of which the most popular by a long shot is Ubuntu. Chrome OS is also Debian-based, so it's a pretty powerful and popular camp. Microsoft and Google, right? IBM and certain other enterprise level things tend to use Red Hat derivative distributions because they have a lot of work that they've done on it to support the enterprise. So anyway, let's see, more questions. Yeah, that's really cool. Yeah, you're welcome. It's a lot of fun. Software just becomes free, and really, if you're a Python user at all, when you use pip, now pip is not on here, when you do pip install, it's very equivalent to, you know, apt install. I mean, you know, my world is like apt installing the things that have to be done at the Linux level to get system resources, and then pip installing things that have to be done at the Python level to get more local Python resources. And you know, between apt install and pip install, you can pretty much get all the software you need for all these stupid server tricks. And you might think there's no graphics, right? But let me exit out of this package, out of this container, right? I'm no longer in the container. Ubuntu at Dewey has now become my, you know, if we look at those diagrams here, right? A very big part of this is knowing whether you're in this or one of these, right? When I'm in Huey, Louie, and Dewey or whatever, I'm in one of these. But when I'm in Lunderwand, I'm in this one here. So that's what you see here as Lunderwand. And you know, I can do graphics. This is a Linux-based calculator that I'm about to bring up. There it is. That is Linux graphics software. So is this extremely silly one here. Sometimes it doesn't flip it to the front, but I'm constantly showing this example. And then the question is, can you use that under a container? Can you do graphics? And this is these silly things like XEyes, but it could just as easily be, you know, Jupyter Lab or Chrome, Google Chrome, any Linux software that has graphics. It could probably be Blender and stuff. But yeah, I figured out how to even do the graphics, Linux graphics stuff under a container. But with you being on Windows 11, you don't need to worry about that. You could install Linux graphics and it'll just magically come up, especially on that parent level. Okay, you have a thing called Conda on your Mac. From what you know, when you create an environment, it just changes where my shell looks for the program. You are right. You are exactly right. Conda is the exact equivalent of something in Python called virtual env. All these things, if you're interested in researching where this whole container world came from, it's from something called chroot, which like goes back to the 70s. So containers are really nothing new. It's just the APIs surrounding them that have made them so popular these days. Back in the olden days, and I used to use chroot every once in a while. I was not a major user, but chroot is the same thing as Conda, is the same thing as virtual env, which is the same thing as containers, LXD, and Docker. They all use basically the same tricks. You know, they create isolated environments to keep your dependencies and resources in the same spot. And they avoid virtualization, right? You will hear the word virtualization and sometimes emulation. Virtualization, bad. Emulation, bad, at least in the interpretations of the olden days, because that's a lot of processing overhead to get virtualization and emulation to work. Some people would say that's not true about virtualization. Oh, come on, then why are containers so popular, right? So containers strip away tons and tons of moving parts. In fact, virtualization would have copies of the whole kernel, large parts of it that don't need to be duplicated. So containers eliminate duplication and they reuse resources from sort of, you know, the parent system in such a way that you can have a lot more of them. You can have more of them. You can have more of them running at the same time. Single instances of them are actually quite a bit smaller than single instances of virtual machines. And the list of advantages go on. You know, containers have and continue to change the face of tech. Yeah, you're an Arch user. Oh, you're pretty hardcore, Lewis. Yeah. So when I talk about the big split between Red Hat and Debian lineages for Linux, yeah, you're one of those people who's like, oh, it's not really true. There's also the Arch lineage. I think that has its own. And I believe Slackware has its own. Tiny Core Linux has its own. There's a bunch out there. There's a lot more lineages and repos. In fact, you being an Arch user, you know Pac-Man. So when I say apt or yum, you've probably used Pac-Man. So they're all the same thing. Yeah, it's interesting that we've had quite a number of users. I'm hesitant to wrap up while there's still people here. So if there's any questions, it's been a pleasure talking with you, Lewis. You've been a great straight person in setting me up for answering questions, making it into a longer video. And the world has changed. I'll do one more drawing to really hit it home. So it used to be very difficult in the Linux world because of something called sysv. And sysv equals services with lots of bash files. And your expertise had to be high. You know, not easy. Okay, so once upon a time, Apple switched to Unix, right? Apple switched the Macintosh to Unix. And when Apple switched the Macintosh to Unix, they were unhappy with the sysd. So they're like, oh, no way, we're not going to make Apple users use sysd. So they created launchd. Launchd equals awesome, but bad license. So the free and open source world, being what it is, copied that. It's not just for launching things, it's for your whole system, systemd. And that D, you know, in all these places stands for daemon. And systemd equals, I don't know, they're like config files, easy config files. Easy config files that connect to the language of your choice. So, you know, I don't know, let's call it what I really want to write. It's a file.py. So those config files can turn a Python file into a system service that run in a very long running sort of way. And in fact, that long running way is very much represented at the bottom of all these things. You know, it's amazing how many times I'll have that email in there. But when you look at one of these things like, oh yeah, I have to vim it. You're always going to find something like a while busy loop, while true colon, sleep one. Sleep one is what keeps it from clobbering your computer. Even just, you know, waking up every 1 second is enough to keep a while true from clobbering your computer. And you put something in between there, and that's a service. While true is what makes this into a never stop, you know, service. It was a lot simpler if I cd into the old directory in there and I look at the original pulse. This was the simplest service I could write. I could even get it a little simpler, but I just import date time, I import sleep, and I say the pulse service has started. And then while true, I create a variable that is equal to a string, you know, of date time now, right? It's really now being pulled out of date time and just being coerced into being a string. And then I open a file inside my temp location in append mode, and I print the string of the date time, and then I write the string of the date time into that file, and it's in a while true loop. And that's a service, right? And that replaces bash. Oh my god, I could hardly tell you how ugly that looks, but if you wanted to see, I mean, you were on Arch, so you know bash, but there's always bash sitting around because it's what virtual env uses. When you go activate source, when you use the source command, which is part of Unix/Linux, right? That's actually a way to execute a external bash file and to create and to make its side effects part of your current terminal. Okay, so source // pi310, where I created a virtual environment. Inside of there's a bin folder. Inside the bin folder, there's a file called activate, which will activate the virtual env, right? So I actually have a virtual env, the equivalent of like Conda and all that. Well, technically Conda is more like a whole software repository system, but creating these virtual environments is an important part of such thing to keep your dependencies isolated. But if you wanted to look at that activate file, oh my god. This is what it used to look like when you had to write things to just start and stop and restart services, and you had to write giant bash scripts every time for every service. And that has gotten replaced by this magic location. The magic location is etc, right? You were on Arch, so you know the etc directory. Arch, there's now something in there called systemd, and inside systemd there's a system directory, system. Oh, I'm not vimming the directory. It's amazing Vim lets you do that. But inside there you keep your services. Scheduler.service, right? So this file is called scheduler.service, and all that gobbledygook of a bash file gets replaced by this extremely minimal stuff, right? It's a service, it's forking, restart every 5 seconds, user group, working directory, execute at startup, standard output, standard error, right? Could it be any easier, right? So the time has come to write Linux services. It's a practical alternative to web development, I would say, really. It was too hard for you, so you switched to Ubuntu. That's fair. So you probably wanted a desktop. So many people, think about Linux in terms of its desktops and stuff, but really, I'm a big fan of Windows with the subsystem for Linux because desktops don't matter. Windowing software is windowing software. The web or whatever, it's just, you're not really using an operating system so much as you're using the syntactic sugar laid over top of it. That's why Apple was able to switch from OS 9, which was all proprietary, to Unix back in 2007 so smoothly and seamlessly. So, use whatever you're comfortable with, desktop wise, and know that just over time, the underlying stuff is all going to become Unix-like operating systems. It's probably going to be the same with Windows eventually. I expect that the thing called, the COM and the PowerShell will eventually go away or just become optional installs, right? So if you're seeing backslashes, it's wrong. If you're seeing forward slashes, it's right. Now, one of the new big innovations is the terminal. Even though I open it full screen and get rid of the tabs, if I were to do function F11, it brings back the tabs, and you can see that you can do a PowerShell. It's not the blue background, but this is PowerShell, right? Here's the backslashes. It's telling you it's PowerShell. You could bring up another one as a old-fashioned command prompt. This is a DOS window, ye old DOS window. There's DOS, there's PowerShell, and there's Ubuntu with its forward slashes and tilde for the home directory. So you can do Linux without, having to really make any kind of major, desktop software change, right? Just keep using Windows. Sounds like you're on Mac. They already made the move. Problem with Mac is that their software repository, their version of apt or Pacman or Yum is brew. Homebrew. Brew stands for homebrew. So Apple just threw up its hand and said, we leave it to the outside world, They don't officially support it. And Microsoft does officially support Debian and Ubuntu. Not that it even needs that official support. It's grown so large and, is so incorruptible. Large and it's just amazing. The Debian branch from which all this stuff that you're seeing me use is derived is just kind of like a miracle. They're some of the good guys of the free and open source world. All right. I've been going for a while. Any more questions or anything? Either Lewis or anyone else who wants to chime in. I'm probably going to be wrapping up soon. It's coming up on 9 o'clock. I've been going for a while. The video definitely achieved its purpose, even though I stumbled a bit on the beginning. And you want to see how many emails I have now in my in here as a result of this? It's up to 30. 30 different cats I have. I should probably try and show the cats directly in the email. I overwhelmed their virus scanning ability. So I'm going to stop that service. Yeah, it was in Munchkin. So you really got to pay attention to your host names and your prompts after you start using containers, because you don't know which container you're in. That's pretty awesome. I'm in. I have 2 of them running now. That's Dewey, and that's Munchkin. LXC list, no, ls fast. And so you can see I have Dewey running, and I have Munchkin running. Now I'm done with Dewey because I just used it for this demonstration purposes. So LXC stop Dewey. LXC, I don't even know, help to less. Alias cluster delete, yeah, that's what I thought. LXC delete Dewey. So found DEWEY. So you've seen me create and do a little bit of stuff and delete a container. So containers are really easy. Have you ever managed virtual machines that fast? Containers really change things. It makes everything so much more convenient. The API has a little bit to be desired, but it is what it is. You just got to get used to these little strange nuances, and the rewards are extremely large. It's a lot like Unix and Linux itself. So I wanted to stop that service. LX, no, it's not a service from this system. It's sudo systemd stop scheduler. Excess arguments, sudo systemd sys tmd. Oh, systemctl. Yeah, it's getting late. It's getting late. That'll stop those emails from sending me cats all the time, which it would continue to do until my laptop goes to sleep. And maybe not even then. I've had instances where I was running the caffeine program where these things kept running as if it really was a server, even when my laptop was closed and everything. So check for any final comments or anything. Oh, you're welcome, Lewis. Tune in, subscribe. I'll try and arrange my videos in some sort of logical sequence and maybe condense down the message a little bit. There's definitely some magic incantations here. So a series of 5 or 6 of them that get all the work done. It's not as much to learn as you might think. And for someone who's actually been on Arch, and even though you changed because it was too difficult, you changed to Ubuntu, and this stuff is if you have the courage to do that, to be on Arch Linux for any period of time, all the rest of this stuff is going to be a breeze. And it's practice. It's like anything else, and that's what these videos about. That's why I'm doing a lot of these as live streams, because I'm trying to get all that practice in. So that's where I wrap up. Thanks for joining me. Thank you in particular, Lewis Heath, right? Lewis Heath. I've really enjoyed chatting with you. And I'll keep the videos flowing. So I'll see you again soon.